learning. Threats are inevitable, but with timely alerts, their effects can be minimized. There are a number of people who die every year due to devastating floods. The number of people become homeless and a number of people die due to lack of proper help after a flood. The lack of timely alerts has always been an issue. So concerning it, delay in alerts in flood-prone areas is the biggest loophole of an economy. Conventional systems run a little low in forecasting floods at the right time, so the proper actions could be taken before any disaster. So we can use machine learning, we can predict floods or forecast floods with better accuracy. So to do this project, we need to install some packages and some softwares. We have to install the Anaconda Navigator and also the Jupyter Notebook. We need packages like NumPy, Pandas, Matplotlib, Flask, Seaborn, etc. So we have to install these packages by using Anaconda prompt. So we will use a pip install for installing these packages. Pip install NumPy. So I already installed it. So I already installed it. So also we need the dataset for the deployment part. We will see the dataset. So this is the dataset. Uh, this dataset contains the temperature, humidity, cloud cover, annual rainfalls. So coming to the deployment part, and also we can download this dataset from different open sources like Kaggle.com, UCI, etc. Let's go to Jupyter. So for doing this project, we have to import that dataset in a file. Firstly, we need to import some required libraries like NumPy. NumPy deals with the high dimensional data, and Pandas. It is used to do statistical data analysis, and we have to import Matplotlib. It is used for 2D visualization, and Seaborn used for high-end data visualization. Here we use PWD. It shows the path where we executing this program. After importing, we need to read the data set. In order to read the dataset, in order to read the dataset, we have to use this pd.read underscore Excel. If our dataset in .csv file, we use the CSV here. It will read the dataset so that we can uh, do the program. Coming to the univariate analysis, it is the analysis to understand the data within a single feature. So here we deployed two plots, and we deployed a distribution plot. It is suitable for comparing range and distribution for groups and numerical data, and it is used to identify what kind of distribution does the data follow. In the graph, we can see the column temperature follow some kind of normal distribution, and also we used another one is box plot. It is used on the length of service and average train, same feature. Uh, Coming to multivariate analysis, multivariate analysis is to find relation between multiple features. Here we've used the heat map. It is a data visualization technique that shows magnitude of phenomenon as color in two dimensions. From graph, you can identify that less correlated values. So here you can see that. Coming to the descriptive analysis, to check the here we use the dataset dot drop October and December. So we can drop that October December. So we need not to use that column. We use the dataset dot head here. First 10 columns. It shows the first 10 rows. If we not mention the 10, it will default show the first 5 rows. So that we have used the function called head, and also we used the dataset dot info provides the summary of dataset. Here we use the describe function used to compute value like count, mean, standard deviation, and give summary type of data. Coming to the handling the missing values, it is used to check the null values. If any null values is present, it is show the true here. So we don't have any null values here. And splitting the data set into dependent independent values. Here we use the dependent variable y and independent variable x. So dependent variable, it shows the output in the dataset, and independent variable, it shows the inputs in the dataset. So feature scaling, it create an object standard scale class. So we will save this transform.save. We have to save this file in form of transform.save. Coming to the decision tree, the decision tree is a function named the decision tree. Create the train and test data and pass it as parameters. We have to check the accuracy score for this, and also the random forest model confusion matrix, and also the same as the decision tree, we have to use the KNN model, random forest model, and XGBoost. So we will comparing the model. So we will compare the above 4 models from sklearn import metrics. It is used to compare the model for evaluating. After evaluating the performance of the model, above 3 models, XGBoost is a better model. So we save this file from joblib import dump. We can save that file. We will saving that file as a flits.save. So after saving this deployment model, we have to build a Flask application. So here we using app.py to build a Flask file. It is used for the server-side scripting. We have to import libraries here. From Flask, import Flask. It used to run our application, and render template used to render the HTML pages. From joblib import load, it will load the model files what we saved in the deployment part. Here we use app equal to Flask name. It is the Flask app what we are creating. Here model equal to load flits.save. It will load the model files. Here we use with app.root. It will render the HTML templates. It used to render some templates. And here we use the app.root data predict. It is root for our prediction, so it will connect to the deployment, and it will predict our threads. Here if we here we use the app.run equal to true, it will run the application in localhost. So let's see, um, once we run and see. Here it's showing some error, so we can also run this program in Anaconda prompt. So let's try there on the Anaconda prompt here. So we have to give the path for output. Uh, we have given the path for the class cap, so running. So here we got the output. So this is the link where our class cap is running. So we have to copy this. After copying this, we have to open the browser. Uh, we have to set this path. Yeah, here the output. So this is the output we got for the Fed prediction. We can predict the Fed here after clicking this. After clicking the predictor, it redirects to the other page where the predictor. So we have to give some values here. The cloud cover percentage, we have to give some 40. An annual rainfall, March May rainfall. So we have to give the values for this. After giving the values, so we can use the predict. After clicking the predict, it will predict the floods and it will show the output of the possibility of severe flood. So it's showing the output here like this. So we can predict the floods by using this machine learning like this. So thank you.